Hello students, welcome to Legacy IAS Academy. In today's video, we are going to discuss about a recent phenomena which is in news, that is the Indian Ocean Dipole. So what is Indian Ocean Dipole? What is its relation with the El Nino? And what is overall impact of this particular weather phenomena on the monsoon of India? So first of all, to understand why this phenomena is used, because the El Nino phenomena is almost certain to affect the Indian monsoon this particular year, and it is believed that due to El Nino phenomena will have deficit monsoon in this particular year. However, some weather scientists also have pinned high hopes on the development of positive phase of Indian Ocean Dipole, also called as positive IOD, and positive IOD is historically has ability to counterbalance the El Nino effect. That means the deficiency in monsoon that could have happened because of El Nino phenomena will not be so severe if positive development of positive phase of IOD develops in the future or in the coming months. So in this regard, the IMD, the Indian Meteorological Department has said that there is almost an 80% chance of positive IOD in the coming months of July and August, and the probability forecast for IOD indicates about 80% positive IOD condition and 15% of neutral IOD between the June-August and July-August 2023 seasons. So before understanding IOD, let us try to understand what is El Nino. Now, El Nino is basically an ocean and atmospheric circulation phenomena which is observed in the Pacific Ocean. So, for example, during the El Nino period, what happens? Like, for example, you understand that during the normal times, what happens near the coastline of South America, we have development of the cold ocean current, because the warm ocean current is pushed continuously from the South America toward Australia and Indonesia, and thus the water from below the surface rises up and occupy this coast of South America, thus creating a cold ocean current. However, during the El Nino years, there is a reversal in the wind circulation, and as there is reversal in the wind circulation, what happens? The warm water is no longer pushed toward the Australia, and thus we have the accumulation of warm water near the South American coast. This accumulation of warm water creates warm ocean current, and this is what we called as El Nino phenomenon. Similarly, we have another event that is called as La Nina, which is reverse of El Nino. During the La Nina, the development of wind from the South America toward Australia is so strong that here we have very strong upwelling or upward movement of the cold ocean current, and that is why here the temperature near the South American coast decreases more than normal. Thus, development of colder than usual ocean current near South America is called as La Nina, while development of warmer ocean current near the South America is called as El Nino. El Nino generally happens after interval of 3 to 5 years if you look at historical time frame. So that is about El Nino. Now, Indian Ocean Dipole is also similar kind of phenomena, and that is why many times it is also referred by the name of Indian Nino. It is, however, playing out in a very smaller area, because as compared to Pacific Ocean, Indian Ocean is much more smaller in size. And this Indian Nino or Indian Ocean Dipole is a phenomena that is observed between Indonesia in the east, and then Indonesia and Malaysia in the east, and then we have the African coastline on the west, especially near the part of Somalia. So one side of the ocean along the equator gets warmer than the other. Basically, IOD refers to a situation where we can divide the entire Indian Ocean into two areas, one the western area, other is the eastern area. So whenever the temperature of one region, for example, western region or eastern regions, become higher than the other region, that is when we call at the Indian Ocean Dipole. Now, obviously, when the temperature of the western side of Indian Ocean, that is near the coast of Africa, is higher than the temperature of eastern side of Indian Ocean, that is near Indonesia and Malaysia, this phase of IOD is called as the positive phase of IOD. Similarly, if the temperature of western Indian Ocean is smaller or lesser as compared to temperature of the eastern Indian Ocean, then this phase of the IOD is called as the negative phase of IOD. In simple way, we also can understand it like this, that the positive IOD when western Indian Ocean has higher temperature and western Indian Ocean is hotter, and negative IOD is when the western Indian Ocean is cooler than the eastern part. If we try to understand this on the map, we can try to understand that if IOD is in positive phase, what basically happens is that we have higher temperature near the coastline of Africa, and we have lower temperature near Indonesia, Australia and Malaysia region. So obviously, the place where temperature is higher, the water will the moisture along with the rising of warm air will go in upward direction, and thus the condensation will create cloud formation. Cloud formation will result into very high amount of rainfall. On the other hand, since during this time there is sinking of the cold air from top to below, the temperature here becomes cooler, there is no convection, no condensation and no rainfall. That's what we can say. During the positive phase of IOD, the western part of Indian Ocean receives, western part of Africa, western part of Indian Ocean receives very high rainfall, while the eastern part of Indian Ocean receives very less or almost no rainfall. Similarly is the case negative phase, when we have increased convection and higher rainfall in Australia, Indonesia and Malaysia, while no rainfall on the western coast of Africa. So if you look at historically, IOD was first time identified as an independent system that also has influencing role on monsoon somewhere in the year 1999. So basically what happens, the air circulation in Indian Ocean basin moves from west to east. If you talk about the normal times, so from the west to east, that means on the surface the air is moving from Africa toward Indonesia, and as the surface air is moving from Australia to Indonesia, obviously this surface air will also drag along with itself the surface water, and thus the water movement also happens from Africa toward Indonesia. And similarly, in the upper atmosphere, the reversal will be observed, where the air movement will be observed from the eastern side to the western side. Thus, a convection cell kind of system establishes itself, and due to this kind of circulation, the surface water in the Indian Ocean is basically moving from west to east, and thus in normal year, the warmer waters of the western Pacific, here we have discussed about in western Pacific Ocean we have warm water. So western Pacific water enters in the Indian Ocean via Indonesian the strait, or that is the water bodies near Indonesia. This is called as Indonesian through flow. So as the warmer water from the western Pacific crosses over to the Indian Ocean, it becomes part of the Indian Ocean and thus raises the temperature of the eastern part of Indian Ocean. And as the temperature of eastern part of Indian Ocean increases, we'll have increased convection, cloud formation, rainfall, and this is what we have associated with the negative phase of IOD. Similarly, if we talk about the positive phase of IOD, everything is reversed. Opposite case involves air circulation, where it becomes slightly weaker than normal. In some rare cases, air circulation even reverses the direction, and the consequence is that the African coast becomes warmer while Indonesian coast is becoming cooler. Now, if you try to understand that what is the relation between IOD or ENSO or Indian Ocean Dipole and ENSO, where ENSO refers to el-nino and southern oscillation, generally we observe that whenever we have positive phase of IOD, it develops at the same time when we have the el-nino years. And on the other hand, the negative phase of IOD is associated with the La Nina conditions developing in the Pacific Oceans. Now, obviously, during El Nino, what will happen? The Pacific side of Indonesia is cooler than normal because we have development to the cold ocean current near the South American coast. So, because of this, what happened? Indian Ocean side near Australia and Indonesia and Malaysia also becomes cooler. So, this helps in development of the positive phase of IOD. Similarly, many studies have suggested that IOD events are actually induced by the ENSO. However, many experts do not agree to this view, and they believe that there are other conditions that actually have led to development of, or that lead to development of the IOD. It is not only the ENSO phenomena. So the overall impact of IOD, if we try to briefly summarize, is that if we have a positive phase of IOD, we'll have obviously increased convection, cloud formation and rainfall over the western coast of Africa, and also since India is nearby, so also we'll have some higher amount of rainfall in India, because monsoon winds will push these clouds and winds to the Indian subcontinent as well. So while suppressing rainfall over Indonesia, Southeast Asia and Australia, higher rainfall is recorded in the western part of the Indian Ocean. The impact will obviously be reversed during the negative phase of IOD, and compared to ENSO events, however, the impact of IODs are much more weaker, and this largely has to do with the fact that Indian Ocean is a much more smaller ocean as compared to the Pacific Ocean. But as we have discussed both from the Australian Meteorological Department as well as from the Indian Meteorological Department, scientists are basically looking out for the hope this year when a strong El Nino is expected to develop in the Pacific Ocean, and generally we can expect the development of positive phase of IOD, which generally begins in the month or should begin in the month of April and May. However, there is a strong example of strong IOD even developing late as well, because as of now the IOD should have developed in April, May, but that has not happened. But that is why scientists are saying that even though it has not developed in the month of April and May, there is an example of strong IOD developing in the later part of the year, and thus in the coming month of July and August, we can see the development of the positive phase of IOD. Then coming to question that what basically triggers the IOD. So obviously one statement is external factors such as ENSO phenomena that is happening in the Pacific Ocean is also influencing the temperature and pressure conditions in the Indian Ocean, leading to development of the Indian Ocean Dipole. However, many scientists have believed or have observed that it is also caused many times by local circulation or subsurface processes within the equatorial Indian Ocean. It does not have to be influenced due to the Pacific Ocean. Even changes that is going on in the equatorial Indian Ocean can trigger the Indian Ocean Dipole. And even if it is triggered by external drivers, IOD events largely develop and mature through internal dynamics. That means overall evolution, impact, and the extent of IOD will depend on the dynamics of the Indian Ocean as well. However, interestingly, what we have to understand that when both IOD and ENSO are strong, their circulation pattern obviously can impact each other. So obviously we are pinning our hope this year that the monsoon rainfall will not so much deficit because of the impact of positive IOD. But do we have any early examples of such phenomena or such events? The answer is yes. Very recently in the year 2019 was a case where IOD event, the positive phase of IOD event has developed during the late monsoon. And this positive phase of IOD developed was so strong that it compensated for the deficit rainfall that was recorded in the first month of monsoon season in 2019. June that month had 30% deficiency, but all this rainfall deficiency was compensated due to the positive IOD. The deficit in June that year was also attributed to the developing el-nino, but that fizzled out later. So similar kind of phenomena we can observe in this year as well. Overall, what we can say in last conclusion that obviously Indian Ocean Dipole, also called as el-nino, is an ocean atmosphere interaction which is very similar to the el-nino fluctuations in the Pacific Ocean, but a much weaker system, obviously due to the smaller size of Indian Ocean than el-nino, and thus has a relatively limited impact. That means Indian Nino does not have so strong influence as we see in its counterpart of the el-nino in the Pacific Ocean. But however, a positive IOD does have the potential to offset the impact of el-nino to even a small measure in the neighboring areas such as India, Africa, and it has at least once in the past also before 2019-1997 delivered admirably on this potential where it has compensated for the deficit rainfall of monsoon in the month of July. So that is all about this particular video. I hope you understood that concept of Indian Ocean Dipole. If you like the video, please hit the like button, share it with your aspirants, as well as subscribe to our channel for more support.